Federal Pacific Electric, abbreviated as FPE Stab-Lok circuit breakers present a concerning history of malfunctions that have prompted recalls by the manufacturer and warnings from the Consumer Product Safety Commission, also known as the CPSC. These issues revolve around three primary areas. Firstly, the breaker's failure to trip during an overload. Secondly, their tendency to trip prematurely. And thirdly, the difficulty encountered when attempting to remove them from the panel. The most alarming problem is the failure to trip during an overload. In situations where the electrical circuit is drawing more current than it is designed to handle, a properly functioning circuit breaker should interrupt the flow of electricity to prevent overheating and potential fires. However, FPE Stab-Lok breakers have been documented to fail in this critical function, thereby significantly increasing the risk of electrical fires. This poses a direct threat to property and life safety. Conversely, these breakers may also trip prematurely, leading to unwanted power disruptions and inconvenience. While not as dangerous as failing to trip during an overload, premature tripping can disrupt essential services and cause operational problems. This erratic behavior undermines the reliability of the electrical system. A further complication arises from the difficulty in removing these breakers from the electrical panel. This can impede troubleshooting efforts, delay necessary repairs, and complicate the replacement process. This issue can be particularly problematic for electricians and homeowners attempting to maintain or upgrade their electrical system. The history of FPE Stab-Lok breakers includes recalls issued in 1983 and 1990. These recalls underscore the severity of the problems associated with these breakers. If these breakers are present in a building, immediate replacement is strongly recommended to mitigate potential hazards. When considering replacement options, it is essential to select circuit breakers that are compatible with the existing electrical panel. There are various brands and styles available, and it is crucial to ensure that the chosen replacements meet the required specifications and safety standards. This ensures proper fit and function within the panel. The cost of replacing FPE Stab-Lok breakers varies depending on several factors, including the number of breakers needing replacement and the specific type of replacement breakers chosen. However, it is vital to recognize that the cost of replacement is considerably less than the potential financial and human costs associated with an electrical fire. This makes replacement a cost-effective investment in safety. In conclusion, the presence of FPE Stab-Lok circuit breakers necessitates immediate replacement due to their documented history of problems and potential hazards. The relatively low cost of replacement offers a substantial return in terms of safety and protection against electrical fires. To further understand the risks associated with these breakers, resources such as the CPSC warning regarding FPE Stab-Lok circuit breakers and recall information from reliable sources can be consulted. It is also important to add that a circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then has to be replaced, a circuit breaker can be reset, either manually or automatically, to resume normal operation. Circuit breakers are made in varying sizes, from small devices that protect an individual household appliance up to large switchgear designed to protect high-voltage circuits feeding an entire city. All circuit breakers have common features in their operation, but details vary substantially depending on the voltage class, current rating, and type of circuit breaker. A circuit breaker must first detect a fault condition. In small circuit breakers, this is usually done within the device itself. Typically, the overcurrent condition is sensed with a bimetallic strip or a solenoid. The bimetallic strip heats up and bends when there is too much current. The solenoid is a magnetic coil that pulls a plunger when there is too much current. Large circuit breakers usually use current transformers to operate a trip solenoid. Protection circuit breaker trip settings must be coordinated with the protected equipment to tolerate momentary high currents such as are caused when motors start, and must immediately interrupt short circuits. The sensing components of a circuit breaker can be tested by injecting a known current and measuring the trip time. The operating mechanism of a circuit breaker must unlatch to allow the contacts to open. It is also usually required to trip the breaker even when the control power is lost. The energy to separate the contacts is usually stored in the breaker, such as a spring charged when the breaker is closed. Small circuit breakers may have a toggle lever to manually trip and reset the breaker, while larger units will use solenoids to trip the mechanism and electric motors to restore energy to the springs. When the contacts separate in a circuit breaker, an arc is formed. This arc must be contained, cooled, and extinguished in a controlled way, so that the gap between the contacts can again withstand the voltage in the circuit. Different circuit breakers use different techniques for arc extinction. Air circuit breakers use blasts of compressed air to blow out the arc. These were formerly used for transmission voltages but are now mostly replaced by vacuum circuit breakers for these applications. Large circuit breakers will have oil to cool and extinguish the arc. The oil decomposes, blasting oil through the arc. Magnetic blowout circuit breakers use a magnetic field to force the arc into an arc chute. As the arc is forced to travel within the chute, it is cooled and extinguished. These are typically used in direct current circuits. Vacuum circuit breakers have contacts that open inside a vacuum chamber. These are widely used today in medium voltage switchgear because they require minimal maintenance. The vacuum interrupter is relatively small compared to air brake circuit breakers. Air-filled or gas-filled circuit breakers may also be used. Air-filled circuit breakers are used for lower voltage applications, while gas-filled circuit breakers use gases such as sulfur hexafluoride to quench the arc. Circuit breakers are classified by their voltage class. Low voltage circuit breakers are used in residential, commercial, and industrial applications up to 1000 volts. Medium voltage circuit breakers are used in industrial and utility applications from 1000 volts to 72,000 volts. High voltage circuit breakers are used in transmission and distribution systems above 72,000 volts. Circuit breakers are also classified by their interrupting rating. The interrupting rating is the maximum current that the circuit breaker can safely interrupt. Circuit breakers with higher interrupting ratings are used in applications where there is a higher potential for fault current. Molded case circuit breakers are commonly used for low voltage circuits. These circuit breakers are assembled as a unit in an insulating case. Thermomagnetic circuit breakers use a combination of thermal and magnetic mechanisms to trip the breaker. The thermal mechanism is used to protect against overloads, while the magnetic mechanism is used to protect against short circuits. Solid-state trip circuit breakers use electronic components to sense the current and trip the breaker. These circuit breakers are more accurate and reliable than thermomagnetic circuit breakers. Miniature circuit breakers, abbreviated as MCB, are used to protect individual circuits in residential and commercial applications. These circuit breakers are typically rated for 15 or 20 amps. Residual current devices, abbreviated as RCD, are used to protect against electric shock. These devices detect imbalances in the current flowing through the live and neutral conductors and trip the breaker if an imbalance is detected. Arc fault circuit interrupters, abbreviated as FSIs, are used to protect against fires caused by arc faults. These devices detect arc faults, which are dangerous electrical discharges that can occur when wires become loose or damaged, and trip the breaker. Circuit breakers are an essential component of any electrical system. They protect against overloads, short circuits, and ground faults. By interrupting the flow of electricity when a fault is detected, circuit breakers help to prevent electrical fires and protect people from electric shock. Regular inspection and maintenance of circuit breakers are essential to ensure that they are functioning properly. Circuit breakers should be tested periodically to verify that they are tripping at the correct current level. Any damaged or worn circuit breaker should be replaced immediately. There are many different types of circuit breakers available, each with its own advantages and disadvantages. The best type of circuit breaker for a particular application will depend on the specific requirements of the application. It is important to choose a circuit breaker that is properly sized for the load that it will be protecting. Overloading a circuit breaker can cause it to trip prematurely, while underloading a circuit breaker can reduce its effectiveness. Circuit breakers should be installed by a qualified electrician. Improper installation can create a safety hazard. Circuit breakers are an important part of any electrical safety plan. By taking the time to understand how circuit breakers work and how to properly maintain them, it is possible to reduce the risk of electrical fires and protect people from electric shock. Some additional information regarding FPE circuit breakers and panels. The issues associated with federal Pacific Electric circuit breakers and panels are complex and have been the subject of much debate and investigation. While it's impossible to provide an exhaustive analysis without extensive testing, here's a summary of the key concerns. Firstly, failure to trip reliably. The most serious allegation is that Stab-Lok circuit breakers frequently fail to trip under overload or short circuit conditions. This means that when a circuit is drawing too much current, instead of interrupting the flow of electricity to prevent overheating and potential fire, the breaker may remain in the on position, leading to dangerous temperatures in wiring and connected devices. Secondly, concealed hazards. Some studies suggest that the failure rate of these breakers is significantly higher than industry standards and that the breakers may appear to be functioning normally even when they are not providing adequate protection. This can create a false sense of security, as people may assume their electrical system is safe when it is not. Thirdly, widespread installation. FPE panels were widely installed in homes and buildings across the United States for several decades, particularly from the 1950s to the 1980s. This means that there are still many properties with these potentially hazardous panels in service. Fourthly, legal and regulatory history. FPE has faced numerous lawsuits and regulatory actions related to the performance of its Stab-Lok breakers. There have been allegations of fraudulent testing and misrepresentation of the breaker's capabilities. Fifthly, conflicting reports and ongoing debate. It is important to acknowledge that there is still some debate and conflicting information regarding the precise failure rates and the extent of the hazard posed by FPE Stab-Lok breakers. However, the weight of evidence and expert opinion suggests that these breakers present a significant safety risk. Several factors might lead to recommending replacement of FPE panels. Firstly, safety concerns. The primary reason to replace an FPE panel is the documented concern about the reliability of the Stab-Lok breakers. Given the potential for fire and electrical hazards, many experts recommend replacing these panels as a proactive safety measure. Secondly, insurance requirements. Some insurance companies may require the replacement of FPE panels as a condition of coverage due to the perceived risk associated with them. Thirdly, difficulty in obtaining replacement breakers. While it may be possible to find replacement Stab-Lok breakers, their availability can be limited, and there may be concerns about their quality and reliability. Replacing the entire panel ensures that you have access to modern, reliable circuit breakers. Fourthly, upgrading electrical capacity. If you are planning to increase the electrical load in your home or building, replacing an older FPE panel with a new panel may be necessary to provide sufficient capacity and meet current electrical codes. Fifthly, peace of mind. Even if there is no immediate need to upgrade your electrical system, replacing an FPE panel can provide peace of mind knowing that you have a safer and more reliable electrical system. Replacement options include complete panel replacement. This involves removing the existing FPE panel and replacing it with a new panel from a different manufacturer. This is generally the recommended approach, as it ensures that all components of the electrical system are up to current standards. Breaker replacement only. In some cases, it may be possible to replace the Stab-Lok breakers with breakers from a different manufacturer that are designed to be compatible with the FPE panel. However, this approach is not always recommended, as it does not address potential issues with the panel itself. When selecting a replacement panel and breakers, consider factors such as firstly, safety certifications. Ensure that the replacement panel and breakers are certified by a recognized testing laboratory such as Underwriters Laboratories, abbreviated as UL. Secondly, amperage rating. Choose a panel with an amperage rating that is sufficient for your current and future electrical needs. Thirdly, number of circuits. Select a panel with enough circuit slots to accommodate all of your circuits, with some room for expansion. Fourthly, brand reputation. Consider the reputation and reliability of the manufacturer of the replacement panel and breakers. The replacement process typically involves the following steps. Firstly, hiring a qualified electrician. It is essential to hire a licensed and experienced electrician to perform the panel replacement. Electrical work can be dangerous, and it is important to ensure that the job is done correctly and safely. Secondly, obtaining permits. In many jurisdictions, a permit is required to replace an electrical panel. Your electrician can help you obtain the necessary permits. Thirdly, disconnecting power. The electrician will disconnect the power to the existing panel before starting the replacement. Fourthly, removing the old panel. The electrician will carefully remove the old FPE panel and wiring. Fifthly, installing the new panel. The electrician will install the new panel and connect the wiring according to electrical codes. Sixthly, testing the new panel. The electrician will test the new panel to ensure that it is functioning properly. It's important to be aware of potential costs involved. The cost of replacing an FPE panel can vary depending on the size of the panel, the complexity of the installation, and the electrician's fees. However, it is generally a worthwhile investment considering the safety benefits. Here's a more detailed breakdown of the potential hazards and considerations when dealing with FPE Stab-Lok panels and breakers. Firstly, understanding the core issues. The primary concern with FPE Stab-Lok breakers is the documented failure to trip reliably when subjected to overcurrent conditions such as overloads or short circuits. This failure can lead to overheating of wires, potentially causing electrical fires. Secondly, historical context. Federal Pacific Electric was a major supplier of electrical equipment in the United States for several decades. The issues with their Stab-Lok breakers have been known for a long time, and there have been numerous investigations, lawsuits, and debates surrounding their safety. Thirdly, independent testing and reports. Several independent tests and reports have indicated that Stab-Lok breakers have a significantly higher failure rate than other brands of circuit breakers. These tests have raised serious concerns about their ability to protect electrical circuits effectively. Fourthly, deceptive practices allegations. There have been allegations that FPE was aware of the problems with their breakers but continued to manufacture and sell them without making necessary improvements or providing adequate warnings. This has led to accusations of deceptive practices and negligence. Fifthly, identifying FPE Stab-Lok panels. FPE Stab-Lok panels can typically be identified by the FPE logo and the Stab-Lok name on the panel cover or inside the panel. The breakers themselves are often characterized by a red or black handle that is stabbed into the bus bar. Sixthly, assessing the risk. While not all FPE Stab-Lok panels are guaranteed to fail, the documented failure rates and the potential for serious consequences warrant careful evaluation and consideration of replacement. It's important to assess the overall condition of the electrical system, the age of the panel, and any signs of overheating or damage. Seventhly, consulting with qualified professionals. If you have an FPE Stab-Lok panel in your home or building, it is essential to consult with a qualified and licensed electrician who is familiar with the issues associated with these panels. They can perform a thorough inspection, assess the risk, and provide recommendations for replacement or other appropriate actions. Eighthly, replacement considerations. Replacing an FPE Stab-Lok panel is generally the recommended course of action, especially if there are concerns about its reliability or if it is showing signs of age or damage. Replacement involves removing the old panel and installing a new panel from a different manufacturer with modern circuit breakers. Ninthly, code compliance. When replacing an electrical panel, it is essential to ensure that the new installation complies with all applicable electrical codes and regulations. This includes proper grounding, wiring, and circuit protection. Tenthly, cost factors. The cost of replacing an FPE Stab-Lok panel can vary depending on the size of the panel, the complexity of the installation, and the electrician's fees. However, it is generally a worthwhile investment considering the potential safety benefits and the peace of mind that comes with having a reliable electrical system. 11thly, insurance implications. Some insurance companies may require the replacement of FPE Stab-Lok panels as a condition of coverage due to the perceived risk associated with them. It's important to check with your insurance provider to determine their requirements. 12th, documentation and records. Keep detailed records of any inspections, repairs, or replacements related to your electrical system, including the FPE Stab-Lok panel. This documentation can be helpful for insurance purposes and for future reference. 13th, long-term safety. Replacing an FPE Stab-Lok panel is a proactive step that can significantly improve the safety and reliability of your electrical system. It reduces the risk of electrical fires, protects your property and occupants, and provides peace of mind knowing that your electrical system is up to current standards. It is also important to note that the Consumer Product Safety Commission, also abbreviated as CPSC, investigated FPE Stab-Lok circuit breakers in the 1980s. While the CPSC closed its investigation without making a definitive finding of a safety hazard, it did acknowledge that the breakers had a higher failure rate than other brands. This further reinforces the need for caution and careful evaluation of FPE Stab-Lok panels. To add some clarification, a short circuit, also known as a fault, occurs when there is an unintended low resistance connection between 2 points in an electrical circuit that are supposed to be at different voltages. This can happen when the insulation on wires wears away, allowing the wires to touch, or when a foreign object creates a conductive path between them. The result is a sudden and massive increase in current flow through the circuit. Several things happen during a short circuit. Firstly, increased current flow. The current can surge to hundreds or even thousands of amps in a fraction of a second. This is far beyond the normal operating current of the circuit. Secondly, heat generation. The excessive current generates a tremendous amount of heat in the wires and components of the circuit. This heat can quickly melt insulation, ignite flammable materials, and cause fires. Thirdly, voltage drop. The voltage in the circuit can drop significantly due to the increased current draw. This can cause lights to dim or equipment to malfunction. Fourthly, equipment damage. The high current and heat can damage or destroy electrical equipment such as appliances, motors, and transformers. Fifthly, potential for electric shock. If a person comes into contact with a live wire during a short circuit, they can receive a severe and potentially fatal electric shock. Circuit breakers and fuses are designed to protect against the dangers of short circuits. They do this by quickly interrupting the flow of current when a short circuit is detected. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Circuit breakers are generally reusable and can be reset after tripping. A fuse is a safety device consisting of a strip of wire that melts and breaks the circuit if the current exceeds a safe level. Fuses are generally single-use devices and must be replaced after blowing. When a short circuit occurs, the rapid increase in current causes the circuit breaker to trip or the fuse to blow. This interrupts the flow of current and prevents further damage or injury. It is important to use the correct size circuit breakers or fuses for the circuits they are protecting. Using an undersized circuit breaker or fuse can cause it to trip or blow prematurely, while using an oversized circuit breaker or fuse can allow excessive current to flow, increasing the risk of fire or electrical shock. Regular inspection and maintenance of electrical systems are essential to prevent short circuits. This includes checking for damaged or worn wiring, loose connections, and other potential hazards. If you suspect a short circuit, it is important to turn off the power to the affected circuit and consult with a qualified electrician. Attempting to repair a short circuit yourself can be dangerous and should only be done by a trained professional. A qualified electrician can identify the cause of the short circuit and make the necessary repairs to restore the circuit to safe operation. They can also ensure that the circuit is properly protected by the correct size circuit breaker or fuse. In addition to short circuits, overloads are another common electrical hazard. An overload occurs when a circuit is drawing more current than it is designed to handle. This can happen when too many appliances or devices are plugged into the same circuit, or when a device malfunctions and draws excessive current. Like short circuits, overloads can cause wires to overheat and potentially start fires. Circuit breakers and fuses also protect against overloads by interrupting the flow of current when it exceeds a safe level. However, overloads typically cause a slower increase in current than short circuits, so the circuit breaker or fuse may take longer to trip or blow. It is important to avoid overloading electrical circuits by distributing the load evenly among different circuits and avoiding the use of extension cords as a permanent solution. Extension cords should only be used for temporary purposes and should be properly sized for the devices they are powering. Ground faults are another type of electrical hazard that can occur when there is an unintended connection between a live wire and ground. This can happen when a wire comes into contact with a metal object that is grounded, such as a water pipe or appliance chassis. Ground faults can cause electric shock if a person comes into contact with the grounded object. Ground fault circuit interrupters, abbreviated as GFCIs, are designed to protect against ground faults. These devices detect imbalances in the current flowing through the live and neutral conductors and trip the circuit if a ground fault is detected. GFCIs are typically installed in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor outlets. Regular testing of GFCIs is recommended to ensure that they are functioning properly. To test a GFCI, simply press the test button on the outlet. The outlet should trip and the power should be interrupted. Then press the reset button to restore power. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. Electrical safety is a critical aspect of home and building maintenance. Understanding the potential hazards and taking appropriate precautions can help to prevent electrical fires, electric shock, and other electrical accidents.